Hello everybody. What if I told you that a single condition involving a geometric mean can instantly prove that three ratios are equal? In today's video, let's crack this powerful result in next few minutes. We are given that this expression ax plus by plus cz is the geometric mean of a square plus b square plus c square and x square plus y square plus z square. And thus we need to prove that x by a is equal to y by b is equal to z by c. So now let's understand the intuitive way to solve this problem. Since in the question it's mentioned that we have a geometric mean, so immediately we can write that ax plus by plus cz the whole square is nothing but the multiplication of these two expressions. And this can be simplified only by expanding and cancelling the common terms. Next, if you try to observe that what we need to prove, you will understand that by taking the pairs of these equation, we can write this particular equation. The first equation can be ay minus b, that is cross multiply these two, and ultimately you will arrive at this equation. Likewise, the other two can be written. In addition, you also need to understand that this inequality, that is ax plus by plus cz the whole square less than equal to the multiplication of these two expressions, is nothing but the Cauchy-Schwarz inequality. And these two parts, that is the LHS and RHS, they are equal only when ABC is proportional to XYZ. That is nothing but the thing that we are asked to prove. So now let's look into the step-by-step solution. Step 1, we can mention that since the geometric mean has been provided, so we can write ax plus by plus cz the whole square is nothing but the multiplication of these two expressions. Then we can expand the LHS and RHS. The way LHS can be expanded is by applying the identity x plus y plus z the whole square and accordingly coming up to this expression. Likewise, expanding the RHS, we can multiply these two expressions and this is where we arrive at. Now, in step 3, let's subtract the LHS from the RHS. And then we can observe that there are some terms in common which can be cancelled out. And you arrive at this expression. Now, rearranging into perfect squares. Now, how this rearrangement should be done? So, this rearranging should be done based on the intuitive idea that we had proposed. That is with these three expressions. So, imagine what does ay minus bx the whole square give you? Likewise, cy minus bz the whole square. And likewise, cx minus az the whole square. And by applying this logic, you can arrive at this equation. That is, you can convert this long expression into perfect squares and arrive at this particular equation. And ultimately, you will get this particular value. Now, in step 4, you need to apply some mathematical logic. So, since each term is a square, the squares are always non-negative. So I can write that ay minus bx the whole square, cy minus bz the whole square, and cx minus az the whole square. All these terms are individually greater than or equal to 0. Now, the only way the sum of non-negative terms equals 0 is when each term is individually 0. So I can write that each of these terms is individually 0 and hence for ay minus bx the whole square, I can arrive at this particular value, that is ay minus bx the whole square. And now taking this bx to the other side, y is equal to bx, and ultimately x by a is equal to y by b. Likewise, I can arrive at these two expressions as well. And ultimately, by comparing all these three values, I can write this final result.